Today, we're talking about something pretty incredible. A new kind of AI that can literally see radio waves, and it might just be the key to making our wireless world way faster and a whole lot smarter.
Okay, let's start with a problem I know you've had. You're in a packed stadium, a busy airport, whatever. You pull out your phone, you've got full bars of signal, but nothing loads. You're just staring at that spinning wheel of death. So what is going on?
Well, it all comes down to a problem we can call the wireless traffic jam. See, even though our networks are getting more and more powerful, they're still kind of stuck using old, inefficient methods.
To get data to your phone, networks have always relied on something called pilot signals. The best way to think about this is that the network is constantly shouting in every direction. Can you hear me now? How about now? Is this a good path? It's just guessing over and over to find the best route.
And this is where we hit a major wall. On one hand, the hardware is getting amazing, right? We've got more antennas, way faster speeds, incredible tech like massive MIMO. But on the other hand, we're still stuck with this huge bottleneck from all those pilot signals. All that constant shouting, it just wastes a ton of the network's resources and ends up slowing us down, especially in busy, changing places.
And here's the real kicker. All that "can you hear me now" chatter takes up valuable space on the airwaves. That spectrum that should be used for your actual video stream or your download. It's an inefficiency that's been baked into our wireless systems for decades.
So a team of researchers looked at this whole mess and basically said, wait a minute, what if we're doing this completely backwards? What if, instead of asking where you are, the network could just see?
And this right here, this is the paradigm shift. Instead of blindly shouting into the dark to find your phone, what if the network could literally open its eyes? What if it could see the walls, the furniture, the people walking around, and then instantly calculate the absolute perfect path for a radio wave to take to get to you?
And to pull this off, they gave the network a brand new set of senses. They hooked up a panoramic camera to the base station for a full 360-degree view. They added a LiDAR sensor, the same tech in self-driving cars, to map out the 3D space. It uses your phone's GPS to know exactly where you are, and then all of that data gets fed into an AI brain that puts it all together.
Okay, so the network has this incredibly rich, detailed picture of the real world. That's awesome. But how does it turn what it sees into a perfect radio signal?
This is where the real magic comes in. Now, the researchers put it like this in their paper. I know, that sounds super dense and academic. But trust me, the idea behind this jargon is actually incredibly cool and elegant.
Let's just translate that. Cross-Modal Flow Matching is basically a new flavor of generative AI. And its special skill is acting like a universal translator. It's been trained to take information from one form, like vision from a camera or 3D data from LiDAR, and instantly translate it into a totally different form, which, in this case, is the perfect language of radio waves. And this all happens in a constant, real-time loop. First, the AI senses the world with all its new tools. Then, it fuses all that data together into one complete, live picture of reality. And then comes the crucial part. It translates that picture, moment by moment, into a precise, predictive map of the radio channel.
And the result of all this? We get a direct path for your data that doesn't need any of those old, wasteful pilot signals. It is a connection that is perfectly customized to the real world as it is, in that exact second. It's really the difference between stopping to ask for directions every block versus just using a live satellite map.
Okay, so the idea is brilliant. But does it actually work? I mean, how much of a difference does it really make? Let's look at the results.
Wow. Okay, this chart basically says it all. The researchers tested their AI against the old pilot signal methods. That shorter bar there, that's the accuracy of the standard approach. And that giant bar next to it, that's the AI. It's not even in the same ballpark. To put a number on it, they measured something called a negative 10.21 decibel error. Now, you don't need to be an engineer to understand what that means. In plain English, it's a tenfold reduction in mistakes. The AI is literally 10 times more accurate at finding the best data path. And that incredible accuracy leads directly to this, a 25% improvement in what's called spectral efficiency. Because you're not wasting all that space on pilot signals anymore, the network can pack 25% more data into the same amount of airtime. For you and me, that just means faster, stronger, way more reliable connections. So when you put it all side by side, the difference is just night and day.
The old way blindly asks, it wastes resources, and it just falls apart when the signal is weak or noisy. This new environment-aware method sees. It uses every last bit of resource for your data, and get this, it's completely unaffected by signal noise because it doesn't need to listen for a pilot signal in the first place.
So this is clearly a huge deal. But what does it mean for the future? Let's zoom out and look at the big picture.
You know, a breakthrough like this is about so much more than just ending buffering on YouTube. This is about building the foundation for a world that's truly, deeply, and seamlessly connected in ways that, until now, have really just been science fiction.
This is the kind of underlying technology that will finally unlock the real promise of 6G. We're talking about totally immersive, lag-free, extended reality. We're talking about perfect, real-time digital twins of entire factories or even cities, holographic phone calls, and of course, the kind of rock-solid, instantaneous connections you absolutely need for things like autonomous cars or drone delivery networks. And it really all comes back to what the researchers themselves concluded. They said that by using computational intelligence, by just being smarter, they can completely replace that old, wasteful communication overhead. They're using AI to solve a fundamental problem in physics and engineering.
Which really just leaves us with one last big thought to chew on. To build the truly connected, instantaneous world that we've all been promised, maybe the very first thing our networks need to do is learn how to open their eyes and actually see it.